Good day everyone, we have here the topic CRC 16, okay? For the subject Networking 1 and Networks and Communications for BSIT 2 and BSCS 2, okay? So just follow the mouse pointer since this topic is very tricky, okay? So for example number 1, determine the block check sequence. Okay, take note, BCS is the block check sequence for the following data and the CRC generating polynomials. Okay, so the given data GX is equal to x raised to 7, x raised to 6, x raised to 4, x raised to 3, x raised to 1, and x raised to 0. Okay, so x raised to 7, that is 1, x raised to 6 is 1, this is your solution, this is your data GX, x raised to 7 is 1, x raised to 6 is 1, x raised to 5 is 0, okay, x raised to 4 is 1, x raised to 3 is 1, x raised to 2, of course, that is 0, and x raised to 1 is 1, and x raised to 0, and that is 1. For the CRCPX, x raised to 5 is 1, x raised to 4, okay, so x raised to 4 is 0, x raised to 3 is 1, x raised to 2 is 1, x raised to 1 is 0, and x raised to 0 is 1, okay. The next step is we multiply the highest exponent, okay? We multiply the highest exponent of the term with the highest exponent of CRC PX, or this is our generating polynomials, okay? So x raised to 5 is the highest exponent, so x raised to 5 times data GX, okay? So we multiply x raised to 5 to data GX, okay? So x raised to 5 times x raised to 7, so we simply add the exponent. So this is 12, 6 is 11, 5 and 4 is 9. We simply add the exponent. X raised to 5 and x raised to 3 is x raised to 8, x raised to 5 and x raised to 1, that is x raised to 6, x raised to 5 and x raised to 0, and of course x raised to 0, this is 1, so we have x raised to 5. Now we have now the string of 1 and 0. So we have x raised to 12 is 1, x raised to 7 is 1, x raised to 10 is of course 0, x raised to 9 is 1, x raised to 8 is 1, x raised to 7 is 0, x raised to 6 is 1, and x raised to 5 is 1. And then the next we have x raised to 4, x raised to 3, x raised to 2, x raised to 1, and x raised to 0. They are all 0. The next, we are going to solve for our CRC of the generating polynomial, okay? So we have just copy, okay? Copy this one, so we copy, and then we divide by our CRC PX, okay? So this is our CRC PX, which is 1, 0, 1, 1, 0, 1, okay? So we have 1, 1, 1, 2, 3, 4, 5, and 6. Okay, so this will be least significant bit. Okay, so we multiply. So 1 times this one is this one. Okay, so 1, 0, 1, 1, 0, 1. And the next, we're going to XOR. Okay, so we're going to XOR. Okay, take note that XOR gate, if the inputs are the same, the output is 0, and if the inputs are different, the output is 1. Okay, the inputs are the same, then the output is 1 again. And if the inputs are different, the output is 1. Okay? So 1, 1, of course, that is the same. So we have 0, 1, 0, that is 1. 0, 1, that is 1. 1, 1 is 0. We have 1, 0 is 1. And 0, 1 is 1. Then bring down 1. Okay, so bring down 1. The next, we cancel out this one. So we have, this is our dividend, our new dividend. So we write there our quotient is 1. So we multiply to this one. So we have 1, 0, 1, 1, 0, 1. And then we XOR again. Okay. So 1, 1, of course, is 0. 1, 0, that is 1. 0, 1, that is 1. 1, 1 is 0. 1, 0 is 1. And 1, 1 is 0. Then bring down 1. Okay? So therefore, we cancel out the 0. And then this is our new dividend. Okay? Of course, the quotient is 1. So 1 times this one will be 1, 0, 1, 1, 1, 0, 1. Okay, in the next we XOR again. So 1, 1, so that is 0. 1, 0, that is 1. 0, 1, that is 1. 1, 1 is 0. 0, 0 is 0. And 1, 1 is 0. And then bring down our 0. Okay. Next, this will be our next dividend. Okay. So if our most significant bit, okay, so most significant is bit 1, and in our divisor the most significant is 1, we simply write the quotient as 1. Okay. So bring down 0. Okay. So the quotient will be, okay, so we write 1. 1 times this one is, of course, this one. Okay. So then, we cancel out this one. So 1, 1, for 0. 1, 0 is 1. 0, 1 is 1. 0, 1 is 1. 0, 0 is 0. 0, 1 is 1. And then bring down another 0. Okay. Then we cancel out this one. Of course, the most significant bit is 1. So we simply write the quotient as 1. Okay. So this is 1 times this one. So we have 1, 0, 1, 1, 0, 1. And the next, we XOR again. So 1, 1, that is 0. 1, 0, that is 1. 1, 1 is 0. And 0, 1 is 1. 1, 0 is 1. 0, 1 is 1. And then bring down another 0. Okay, so bring down another 0. We cancel out this one. The next, our most significant bit is 1. So we simply write 1. Okay, so write 1. And the next, 1 multiplied with this one, so the answer is unchanged. Okay, so the answer will be 1, 0, 1, 1, 0, 1. And the next, we XOR again. So 1, 1, that is 0. 0, 0, that is 0. 1, 1 is 0. 1, 1 is 0. 1, 0, that is 1. And 0, 1 is, that is 1. Okay. The next, bring down another 0. Okay, so we bring down another 0. So we cross out this one. We cross out this one. So this will be our next dividend. But the most significant bit, as you can see, the most significant bit is 0. So therefore, we cannot divide 0 by 1. So we write 0. So write 0. And then bring down another. Okay, so bring down another 0. Okay. So bring down another 0. So we cross out 1 and 2. Okay, so the result will be, okay, so XOR 0, 0. Okay, so 0, 0. Okay, so 0 times this one is 0, 0. So 0, 0. So 0, 0, 0. 0, 0 is 0. 0, 0 is 0. 1, 0. XOR again. So 1, 0 is 1. 1, 0 is 1. 0, 0 is 0. And then bring down 0. Then cross out the 2, 0. So therefore, our CRC is 0, 1, 1, 0. Okay, so this is now our CRC, which is 0, 1, 1, 0. Now, what we are going to do for our CRC, we will append this CRC to our data GX. So let's change this 0, 0 to our CRC. Okay, so let's change that 0, 0 to our CRC. Okay, copy, paste. So this will be now our data to be transmitted. Okay, so this will be our data to be transmitted now. That is, this is your data GX and this is your CRC, generating polynomial. Okay, so this is now your CRC generating polynomial that we will append to our data GX. Okay, so this will be our data to be transmitted. Okay, and next we have okay, summary. We have the summary now. Okay, so therefore, this is our CRC. Okay, so this is our CRC. The block check sequence is your data GX plus your CRC generating polynomial, which is we solved a while ago. Okay, so we append the 0, 1, 1, 0, 0 to our data GX. Okay, this therefore the transmitted signal is 1, 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, 0. Okay, and of course, at the receiver end, okay, so at the receiver end, okay, so at the receiver end, again, that block check sequence, okay, a block check sequence will be divided by CRC TX. Okay, so at the receiver end, we are going to check for an error. Okay, so again, the block check sequence is this one. Okay, so divided by our CRC TX. Okay, of course, so this is now our dividend. This is our first dividend. Okay, so this is our first dividend. So the most significant bit is 1. So of course, you write the quotient as 1. So 1 times this one is of course this one. This data is unchanged. Okay? Then we XOR 1, 1, and that is 0. 1, 0 is 1. 0, 1 is 1. 1, 1 is 0. 1, 0, 1. 1, 0 is 1. And 0, 1 is 1. Then bring down 1. Okay? So cancel out that 0. And this is now our second dividend. Of course, the most significant bit is 1. So therefore, we write the quotient as 1. So 1 times this 1. So of course, this is the result. Then we XOR again. XOR 1, 1, that is 0. 1, 0 is 1. 0, 1 is 1. 1, 1 is 0. 1, 0 is 1. And 1, 1 is 0. Okay, so cross out this 0 and bring down the next one. Okay, so this will be our third dividend. Of course, the most significant bit is 1. So therefore, we write the quotient as 1. And if the most significant bit is 0, then of course we write the quotient as 0. Okay? So to continue, multiply. Okay? So we have this data. So then we use the XOR again. 1, 1, that is 0. 1, 0 is 1. 0, 1 is 1. 1, 1 is 0. 0, 0 is 0. 1, 1 is 0. And therefore bring down the first 0. Okay? The next, we cross out this one. Okay? So then the fourth, okay? So the fourth dividend will be 1, 1, 0, 0, 0, 0. Okay? So of course the most significant bit is 1, then we write there 1. Okay? So we write there 1. Okay? So we write 1. Okay? So 1 times this one is, of course, and then we XOR. 1, 1 is 0. 1, 0, of course, 1. 0, 1 is 1. 0, 1 is 1. 0, 0 is 0. 0, 1 is 1. Then bring down 1. Okay? So we cross out this 0. And the next, this is our fifth dividend. Okay? Of course, the most significant bit is 1, so we write there 1. And then multiply, so we have, and then we use the XOR again. So 1, 1, that is 0. That is 0. Then 1, 0 is 1. 1, 1 is 0. 0, 1 is 1. 1, 0 is 1. 1, 1 is 0. And then bring down another 1. Okay? So we cross out this 0. The next, we have the last dividend. So we have 1 as the most significant bit. So we write there 1. Okay? So we write there 1. Okay? Then multiply to our divisor. Of course, the divisor is unchanged. So we have, and then we have 1, 0, 1, 1, 0 as your divisor. And then we use XOR again. So 1, 1 is 0. 0, 0 is 0. 1, 1 is 0. 1, 1 is 0. 0, 0 is 0. 1, 1 is 0. So therefore, if we bring down 0 and 0, our answer will be all 0. Okay, so meaning there is no remainder. Okay, so if there is no remainder, then it means that there is no error. Okay, if you have some question, then you can ask me through our GC. Okay, so the solution will be posted on our Facebook. Okay, so I hope you understand the procedure through this video, and God bless us all.